Yeah, so this is a question from GATE 2023 from electrical engineering. The question is the value of parameters of the circuit shown in figure are R1 equal to 2 ohm, R2 equal to 2 ohm, R3 equal to 3 ohm, L equal to 10 millihenry and C equal to 100 microfarad. For time t less than 0, the circuit is at steady state with the switch case in closed condition. If the switch is opened at t equal to 0, the value of voltage across the inductor VL at t equal to 0 plus in volts is. So the question is like for t less than 0, for a long time the switch this K is closed, is kept closed, right? And what happened at t equal to 0, this switch is open and we need to find what is VL. Okay, so when the switch is closed for a long time, this is a DC current. So what happens? The inductor will act as a short for this DC current, right? After at steady state. And what happens to capacitor? It will like a it will act like an open circuit, or the capacitor will charge to a particular voltage and there won't be any current through the capacitor, right? So I will just redraw this circuit for t less than 0, right? So switch is closed. I have the resistor R3 which is equal to 3 ohm. There is a DC current here, that is 10 ampere. This is the resistor R1 which is 2 ohm, and the inductor I will draw like a short circuit because at steady state it's like a short. And here there is R2 which is again of 2 ohm. Now the capacitor I will draw like an open circuit because it gets charged and there won't be any flow of current through this. So the current through this is 0 ampere, right? And this is connected, right? Now if you carefully see, this 3 ohm and this 2 ohm is now in parallel with 10 ampere. So the current 10 ampere will split like this a current I1 and there will be a current I2, right? So what is I2 here? I2 is like the current 10 ampere is split across the two parallel resistance, right? So I2 is equal to 10 ampere into the opposite resistance to 2 ohm, that is 3 ohm, right? So 10 into 3 ohm by 2 plus 3, that is sum of the resistances. So it is 10 into 3 by 5, that is 6 ampere. So this current is actually now 6 ampere. So what is this current? I1? I1 is actually now 10 minus 6, that is 4 ampere is actually flowing through 3 ohm. Okay, now if you carefully see, the current flowing through this resistor is actually 6 ampere. Okay, so there will be voltage drop across this 2 ohm and that is equal to 6 into 2, that is 12 volt, right? So that voltage is across these two nodes. So what is the voltage drop across the capacitor now? That is the voltage at this point, right? The same as this point. So the voltage across the capacitor built will be same as this 12 volt. So this voltage will be equal to 12 volt, right? So if I draw this as a current source and a voltage source, I can draw it like this. So I have a resistor, I have a current source here as 6 ampere, and this is 2, and this is a voltage source plus minus as 12 volt, right? And why I draw that this I draw because at t equal to 0, right, the switch is open. The switch is now open circuit, K is open circuited, and so when the switch is open circuited, what happens? This current is now 0 ampere. So the entire 10 ampere current will flow like this, right? And this will be splitted across this 2 arm. But we know the inductor won't change the current through flowing through it, like instantaneously it won't allow to change that current instantaneously. It will try to maintain the same 6 ampere to flow through it. So that's why instead of this inductor I have drawn a 6 ampere current source. And what happens here in capacitor, there also there will be flow of current, but the capacitor will try to maintain that voltage across it as 12 volt, right? So since at t equal to 0 or at t equal to 0 plus, this circuit is like this, the flow of current through this 2 volt is actually now 6 ampere. Since this is 10, so what is the current here? What the current through this 2 ohm is now 4 ampere, right? 6 plus 4 is 10, right? So since this 4 ampere current is flowing like this, there will be a potential drop like this, plus minus 4 into 2, that is 8 volt. 8 volt potential drop will be there across this 2 ohm resistor. So what is the total potential drop across this? Across this now is 12 plus 8, right? That is actually equal to 20 volt, right? Now if we see the above path, there is a current flow of 6 ampere here. So definitely there will be a voltage drop across this, that is 6 into 2, that is 12 volt. Okay, so what is the remaining voltage drop here, that is plus minus, which is equal to the VL, voltage across the inductor. So VL is actually equal to the net voltage, that is 20 volt minus the voltage drop across this 2 ohm, right? That is minus 12. So this is equal to 8 volt. So VL will have a 8 volt. So 8 plus 12 here is 20, and here it is 8 plus 12 20, right? So the question is, what is the voltage VL at t equal to 0 plus? What is that? That is 8 volt. So answer is 8. So this is another question from GATE 2023. The question is, for the circuit shown in the figure, V1 is 8 volt. So this V1 is actually 8 volt DC, and I1 is 8 ampere. So I1 is 8 ampere. The voltage VAB in volts is, so I need to find what is the voltage drop across this 3 ohm VAB. Okay. So in this network, what we will do, we'll consider this as the reference node. That is, this is connected to or this is assumed to be ground. Okay. And what we'll do, we'll just apply the Kirchhoff current law, KCL at node A. So KCL at node A. Okay. So say the voltage at this node is, say, VA with respect to ground, right? So on applying Kirchhoff current law, the current through this resistance plus the current through this resistance plus current through this resistance is equal to 0. So what is this current? This current is the voltage across the 0.5 ohm by 0.5. So across the voltage across 0.5 is the voltage at VA, that is VA minus V1 by 0.5. So VA minus V1 by 0.5, that is this current plus this current. So what is this? The voltage across the resistance 3 ohm, right? So VA by 3, that is this current, plus what is this current? This is voltage across 3 ohms, that is VA minus VB. VB is now actually ground, right? So again it is VA by 3. This is equal to 0, right? Here V1 is actually 8 volt. So if I substitute it, VA minus 8 by 0.5 plus VA by 3 plus VA by 3 equal to 0. So I'll just club the values of VA. So I have 1 by 0.5 plus 1 by 3 plus 1 by 3 and the remaining term is minus 8 by 0.5 equal to 0, right? So VA 1 by 0.5 is 2 plus 1 by 3 plus 1 by 3, 2 by 3 is equal to 8 by 0.5 is 16. So VA is equal to 16 into 3 by 8, right? So 8 2 into 3 is 6, right? So VA is actually 6, right? Now question is to find what is VAB. So what is VAB? VAB is voltage at A, that is VA minus voltage at B, right? VA is now 6 and VB is now 0, right? This node voltage is actually the ground, right? So VB is 0. So what is the voltage VAB? VAB is actually 6 volt. So answer is 6. Yeah, so this another question from GATE 2023. The question is, consider the op-amp based circuit shown in figure. Ignore the conduction drop across diode D1 and D2. All the components are ideal and breakdown voltage of Zener is 5 volt. Which of the following statement is true? So a circuit is given and the option is like the maximum and minimum values of output voltage V0 is say some 2 voltage. So we need to find what is the maximum and minimum value of voltage at Vout. So that is the question. Okay. So now if you observe here in the circuit, a sinusoidal input is given and it is like an inverting configuration, while in the feedback we have a Zener diode and 2 normal silicon diode, right? And all diodes are ideal. Now we'll consider the case when the output is positive or negative. So we will find for those cases what happens. Okay, so I have a sinusoidal input here. Okay, so say because of this, say V0 is positive. Okay, so where V0 is positive and having a higher value, some large magnitude of V0 is available here, or maximum value of V0 is there. So what happens if this is plus, if this node is plus, then diode D2 is like on and diode D2 is like off, right? So I can say it's like an open circuit, and since it is ideal, it is like it is completely connected, right? This is like a closed switch. Now coming to the Zener diode, what happens? It's like a reverse bias. This node is plus, right? So because of that, there will be a voltage drop across the Zener, like plus minus. And what is this volt? 5 volt. So in effect, I can draw the circuit as like this, right? There is some input voltage when Vout is positive max. Okay, so what is the voltage here? This is plus minus 5 volt, right? So Vout is actually the voltage across this zener, right? Because this is virtual ground, so the voltage across zener will be the output. So V0 will be equal to 5 volt, right? Now we'll consider the case when V0 is negative, right? When say V0 is negative max. So when V0 is negative, here this point or this node is actually minus max. So if it is negative, what happens? This diode is for a reverse bias, so it is like an open circuit, right? And if this is open circuit, definitely this there won't be any current flowing through this, so I can neglect this path. Okay, what happens to diode D1? This may be since this is negative, diode D1 will be now short circuit because it is forward biased, which means I can draw the circuit as, right, this is 1k, this is 1k, and I have the input Vin, right, and this is negative. So what is the when does this become negative? When the input is in the positive cycle. Okay, in the positive cycle the maximum is 10 volt, right? So what is the output? 10 into minus Rf by R1, so minus 1k by 1k. So this is actually 1k cancelled, it is minus 10 volt. Okay, so the maximum positive is 5 volt, and maximum negative peak is actually minus 10 volt. So answer is plus 5 maximum and minus 10 minimum, right? So answer is D. So this is a question from GATE 2023. The question is, for the circuit shown, if I equal to sine 1000t, the instantaneous value of the Thevenin's equivalent voltage across the terminals AB at t equal to 5 millisecond is. So I need to find what is the Thevenin equivalent voltage across AB at t equal to 5 millisecond, right? So for this, what I will do, I will just convert this network or the current source to a voltage source. So what I have to do, I need to multiply the current with the impedance kept in parallel to it, right? So this is Z. So Z into I. So what is that? I will just convert this circuit as plus minus. So here I will convert this current to voltage source. So the impedance will be as same, voltage in series with the impedance. So I have the resistor here and inductor same as that. So this is 10 ohm, this is J10, and it is connected in series with the voltage source. Okay, so voltage source value is the current I into the impedance 10 plus J10, right? So what is current I? I is sine 1000t. So sine 1000t, that into the impedance, that is 10 plus 10J. So this is the voltage here. Okay, V I will call, right? And the remaining remains as same. So this is for Ix. Okay, the Ix is the current through this 10 ohm resistance, and the impedance of this capacitor is minus Z10. This is A, this is B, right? Now what I will do, I will apply the KVL across this loop. So starting from here, the voltage V, that is KVL in loop. Okay, so this voltage, the voltage is I into the impedance, that is 10 plus 10J. So this is minus this plus, right? 10J into sine 1000t. So that is the voltage source here. Now the current flows like this, right? And if we call this as a single impedance, the voltage drop across this is like here plus, across here this plus and this minus. So I can say this current into the impedance. So let the current be I. Okay, and what is I here? The same current is flowing from here to here, and the same current is actually flowing like this also. So this I is same as Ix, right? So I is actually equal to Ix, right? Yeah. So in this loop or in this mesh, the current is Ix. Okay, so what is the voltage drop across this impedance? That is minus 10 plus 10J, which is the impedance of R and inductor, that into Ix, that is the voltage drop, and coming here it is 4x, right? And minus 2 plus, so it is like plus 4Ix. And now coming here, if you see, there is again an impedance of 10 minus 10J, right? A resistor capacitor combination, and because of this there will be a voltage drop like this, plus minus. So what is the impedance? That is 10 minus J10, and that into Ix, that is the voltage drop, that equal to 0, right? Now we'll just simplify this. So 10 plus 10J sine 1000 t minus, so if I club this ix, what happens? I have 10 plus 10j, right? I have taken minus outside, so this is minus 4 and this is plus 10 minus j10, that into ix equal to 0, right? So 10 plus 10j into sine 1000 t minus, so 10 plus 10 is 20, 20 minus 4 is 16, right? And 10 minus 10j is 0, so plus 0 equal to 0. So what is and this is into ix, right? This into ix. Now what is ix now? Ix is equal to if I bring this term to RHS, ix will be equal to 10 plus 10j into sine 1000 t by 16. This is ix, right? Now I want to find what is VTH here. VTH is the voltage across A and B. So what is this VTH? VTH is the voltage across this 10 and minus 10. So what is VTH from the circuit? VTH is equal to the resistance impedance 10 plus minus 10j. So 10 minus 10j, that into ix, that is actually the voltage across AB, right? So if I substitute this ix here, what happens? 10 minus 10j into 10 plus 10j into sine 1000 t by 60, right? So 10 minus 10j into 10 plus 10j is a minus b into a plus b, right? So a square minus b square. So 100 minus 100 into minus 1. J square is actually minus 1, right? By 16 sine 1000 t. So this is actually 200 by 16 into sine 1000 t, right? So this is VTH. We need to find what is VTH at t equal to 5 millisecond. So if I substitute here, VTH is equal to 100 by 8 into sine 1000 into 5 milli, right? Or 100 by 8 into sine 5. So in radians if you take, the value will be equal to minus 11.98 volt. So that is VTH, right? So the answer is minus 11.98.